Hello and welcome to the third computer graphics practice video. So in this video we'll be looking at the Hello ThreeJS task, which comes after the Hello Web Shell task. So you need to do the other one before this one. But let's move on to this one here. So here we'll be using a library, ThreeJS, which is built on top of Web Shell. And as you saw from the previous task, pure Web Shell can be a bit tedious. So of course, if you want to do very low-level things that you don't want much overhead in, like in terms of performance, then you might want to program pure OpenShell Web Shell. Or if you're actually writing a library or some kind of application or plugin exactly on top of Web Shell to create a framework or something over it. But in this task and in many later tasks as well, we'll be using this ThreeJS library. So you can go to this homepage. So currently it's revision 87. Now ThreeJS has a very involved or very rapidly developing community. So you can go to GitHub, and there's lots of commits, lots of issues, pull requests. This revision kind of changes. So this has changed. It says 6 days ago. So there are always new revisions released, new updates done. And some of those actually kind of break some things. So we'll see how using this library this semester goes. If you're watching this video at some later date, then I don't know, this revision 87, maybe we are now at revision 187. Don't know if this video is relevant then or not, but well, in most of the previous now 10 or so 20 maybe revisions, not much has changed in terms of general strategies, so it should still be useful later on as well. But feel free to browse different demos, different applications, featured projects. There are lots of examples. You can do pretty cool stuff, like this cloth here. It's kind of I don't know if this does something or not, but lots of awesome things. So feel free to browse, and you can also see the source code for all of those examples. Of course, you might run into some problems, and then you also want to see how to do some of the things you want to do. For example, there are some lights here, so hemisphere light or some other let's see some blending examples. Some of those things we'll be looking in our course as well. But currently this is just your Hello ThreeJS initial task. So let's download this code here. And the task is again the same. You need to draw an equilateral triangle. So you can open this code and the browser, and what you should see is this black canvas. And it should also say Web Shell renderer, whatever revision you have. Now let's look at the code. So what we are doing is we're including this r87.js. So when you download when you want to download ThreeJS, then there are some hints. So first of all, if you press this button, then this is going to download you some, I don't remember, some couple of 100 megabytes, 200 megabytes of examples, models, all sorts of things. So you might not want to download this one. unless you do want lots of examples and all of that along with that download. But what you can do is go to the source code and, for example, take the maybe the master branch here, and there is this build folder, and you can download either the minified version or the normal version from here as well. There should also be somewhere different tags where you can filter out different revisions, whatever revision you want. But yeah, so I recommend to download ThreeJS from here if you need it. But it's also included in the zip file here, so you don't need to actually do anything additionally to download in this zip. The 3R87.js is in this zip file. Of course, if the revision changes and you need to see what R88 holds in store, then you might want to download that and then replace this address here. Okay, but in ThreeJS we have a couple of important variables. So we have a renderer, a scene, and there's also this camera. So before looking at this part, we should look at this line here. So this line is really important, and this is what actually renders something on this canvas here. So and you can see you need a renderer, you need a scene, and you need a camera, and you need to tell the renderer to render some scene with some camera. Now, what this means is that this renderer is this WebGL renderer. You see, we are not getting any context from the canvas, but WebGL will do this by itself. Also, it will append our own canvas in the document. So if you look at the HTML, all we have here is a div element. So this is just your a box element. It's a bit more than that, but let's keep it simple for now. And inside this line will add ThreeJS's own canvas. But this renderer will need to know the width and height. So those are the values that before we had defined on the canvas ourselves, but now we define them for the renderer, and corresponding canvas element will be in those dimensions. Next we're going to create a scene. So scene is a collection of objects that are in your 3D environment, and you also need a camera to actually see this three-dimensional environment from some angle. Now, just as a quick side note, what this means is that there is some kind of three-dimensional world somewhere, so X, Y, and Z, and there are some objects in that world, so some cubes, maybe some spheres, some kind of pyramid shape, and so on, or a tetrahedron or something. So, and you also need to have a camera that is looking at this scene and seeing some of the objects from some angle and displaying them on your computer screen or monitor or viewport. So this viewport is kind of this area where all of those objects in the scene are projected, and this is what you see in the end. We'll be looking at this in more detail later on, so in this task it's not that important, but it's just interesting to already start thinking about a three-dimensional space where your objects live in. So this is why we actually need this scene. It's just a container. We add stuff into this, and when we say render a scene, it will render all of the objects in it from this camera. Now this is an orthographic camera, don't worry too much about it, it just means that there won't be any perspective distortions. It's just kind of projects objects flatly, and we're going to have a triangle in our scene, so it just shows us this triangle. But we do need to think about where our camera is located and where is it looking at and so on. So currently this camera is positioned 100 units on the z-axis, and it's looking at the XY plane, so you can position your triangle on the XY plane and it will see it. Now this, should you add your camera to a scene or not, has been a topic of controversy, so sometimes it's needed, sometimes it's not, so I don't know, I just add it here, it doesn't do anything. But we do have this draw triangle again, and actually this structure isn't all that good, because you can see that in this draw triangle method there is this scene add triangle, so it doesn't actually draw a triangle, rather it creates one and adds it to a scene, and this call actually draws a triangle. But just for consistency with other tasks, I have called it this. Right, but now we get to a very important part. So in ThreeJS, the objects are called meshes. So a triangle will be a mesh, and this mesh will be consisting of a geometry and a material. What geometry exactly and what material exactly will be depends on the mesh. There can be lots of different ones. Currently here we have just this one geometry, this empty class. There is also this buffer geometry. There are also built-in box geometry, torus geometry, and so on. So that already have already have algorithms that create some defined primitive shapes, but in this task we want to create the triangle ourselves. And next there is this material, same thing. This one is mesh basic material. This will just color a single color, but there are other materials that kind of shade depending on light sources and so on. But actually in the later tasks as well, we'll be using mostly our custom shader materials, where we can write the shaders and corresponding shading algorithms ourselves. But just so you know, ThreeJS offers a big variety of different things. This documentation page will be our best friend here, so you can see different materials of here. So different materials for lines, Lambert material will be looking at what this is, Fong material will be looking at what this is, and so on. But yeah, the shader material allows us to define our own custom shader code, so this is also useful. Now, so let's try to add or follow the task. So it says that we need to create three vector3 objects that specify or hold our vertex coordinates of our triangle. Then we need to add them to the geometry, and another thing is that we also need to add a face. So a triangle doesn't only consist of three vertices, but it also consists of a face. The thing here is that you can define vertices and faces separately, because if you think about a triangle fan structure, then you want your faces to share different vertices. Also, at times you want them to share vertices, and at times you want duplicate vertices. So it will depend on the actual shape you're trying to great. Of course, this isn't like you're not going to write all of the vertices by hand and all of the faces by hand each time. Rather, you either have some kind of an algorithm that loops over the vertices and constructs the faces, or they will be imported from a model file, and then those will be constructed by an algorithm reading the file. But okay, so let's create maybe vertex 1, which will be a new tree vector 3. So at this point we again don't know what is our coordinate system, so I'm going to put just 100, 100 and 0 here. So at this point now I might be wondering, this vector 3, how is this really how they define it? So I want to go to the documentation, find the vector 3 and see that yes, this is how it's initialized. I could also apply all those methods on our newly created object if I want. Okay, so 100 and 100 on x and y. So this goes to the right. So now we might want to create another one that's perhaps up, and then another one that's to the left, assuming that the coordinate system is this way. So what I'm thinking here is that perhaps we have a system like x and y, and now I have just created a triangle where we have a coordinate at 100 and 100. So this is my vertex A. I should name it like this in code as well. Next we have 100 on x and 0 everywhere else. So 100 and 0 is our second vertex. And our third is minus 100, so this will be here. So this isn't all that pretty. And another thing that we should see here is that I have defined this in that order. Well, it depends on in which order I will define the face later on, so you'll see this in a moment. So let's get back to the code. We have some vertices, great. And now it says that we need to put them in the geometry vertices array. So at this point we might want to check out what is inside this empty geometry that we have created before. So let's log this out, and you can see that we have this geometry. I wonder if I can verify this. Yes, that's better. And I can open this up. I can see lots of different properties of this geometry. So there we have an array called faces and an array called vertices, and both of these are currently empty. Everything else doesn't concern us right now. So there is this vertices array. Let's go back here, and the task says let's add those vertices to that array. So vertices in JavaScript there is this function push, and now I'm wondering if I can do something like that. And I'm going to see if I'm going to get an error. Nope. And we have this geometry, and if we look at the vertices now, there is 3 vector 3s inside this array. And next we want to create a face. So there is one face, let's call it face. This is a new face 3, and now we want to put indices of the vertices that constitute this face. Now again, we might want to check out the documentation to see how this face needs to be constructed. There are other things here as well. like some face normal, face color, material index, those doesn't concern us because they're optional. But you can see that vertex A index, vertex B index, and vertex C index. So those will be the indices of the vertices in the vertex array that constitute this face. And currently what we have here might be 1, 0, 1, and 2. Right. Now we have a face, and we also need to add this face to our triangle. So let's take geometry, faces, and let's push this face in there. And now we should have a solid triangle, but as you can read from the comments, there is a question of the face facing the camera. So let's go and see if currently we are seeing a triangle. No, we are not. But does this mean that there is no triangle? So one common thing to do when you are seeing a black screen is checking out do we have the face facing backwards or not. So the most easiest way is to exchange two vertices here, and now we see a triangle. So we didn't actually change any of the coordinates, but we changed the order. So what this meant is that those vertices we have here, currently this will be defined in a clockwise way in relation to the camera. So this means that this is the back face, and it will be colored. It will not be rendered to optimize performance. But if we just happen to exchange those two vertices, and let's say that this will be the second vertex in this face, and this will be the third vertex, then we will be defining the face vertices counterclockwise order, and then it will be the front face. Of course, a more logical way to do this would be to just think about those coordinates first, and maybe put 100 and 0 as the first one, and then 100 and 100 as the second one. So, and then we can have a nice 0, 1, 2 here as well, and we will see this triangle. So what this task is about is creating some vertices, creating a face, getting to know ThreeJS structures, and making sure that your vertex is not backface, that your triangle is not backface colored. It will be visible. And of course, as with previous tasks, take into account this position and make the triangle equilateral. And if I call this to a triangle with other coordinates or change those coordinates, then I should get many triangles, as many as I call this function. For the coordinate system, you can kind of see that this will depend on actually this orthographic camera and this canvas white. So currently it's rendering such that the center 0, 0 is in the center, and this will be the positive x, and I think 400 is the edge here. Minus 400 is here because this entire white is 800, and 500 above, and 250 above, and minus 250 below. So yeah, if I were to change the orthographic camera parameters of those values, then it will be different, of course. So that's pretty much all about that. So get to know ThreeJS and see what interesting things you can do here.